Hi people, welcome back. Session 3. Scary title for this one, biomarkers of stress. Not really, it's just talking about some of the biological markers that we can measure in someone's body that can give us a handle on the amount of stress that they're under. So on the previous session we looked at 2 interview questionnaires, the Holmes-Rahe stress assessment and the perceived stress scale. There were ways in which we could ask someone to fill out a survey or respond to questions that quantify the amount of stress that someone's under. This is related to this, except rather than ask questions, we can actually measure some biomarkers, some chemicals or responses in people that quantify stress. And that's hence the term biomarkers of stress. I guess the only rider for using biomarkers to evaluate or quantify stress is that they really shouldn't be taken as in isolation as an indicator of stress. So you'll see as we go through in this first Camtasia that we're doing, there's actually lots of biomarkers for stress. Things like body mass index, insulin sensitivity, that can indicate stress, but they shouldn't be taken in isolation to indicate stress only. Okay, so you should actually use the biomarker for stress and use it in context with the patient's concurrent health history and other measures of stress, such as the sort of Holmes-Rahe scale or the perceived stress scale. Okay, so let's move on. Couple of terms and concepts to deal with before we jump into biomarkers. 2 words we've got to deal with and understand the distinction between them is homeostasis and allostasis. Homeostasis you probably have heard of and have a decent understanding of. And it's the process that goes on within us that auto-regulates to maintain a constant internal environment. So in other words, it's a mechanism by which we, the organism, auto-regulates to maintain an internal environment in a stable state. And this is really important for things like blood pressure, for things like core body temperature, for things related to constant things that are being kept constant. So blood pressure, blood glucose levels, all sorts of things that we need to keep constant. Blood calcium levels is another one, but pH and blood pressure and core body temperature. There's some really big things that are controlled through this homeostatic mechanisms. But there's another term that sits on top of homeostasis, and it's relevant to stress, called allostasis. Now, let's have a read of that second definition there. Allostasis is the process whereby an organism maintains physiological stability by changing parameters of its internal milieu by matching them appropriately to environmental demands. Now, you might think that sounds like a very similar definition to what homeostasis is, and you might ask yourself what that difference is. I guess the easiest way to understand the difference between allostasis and homeostasis is that allostasis sits on top of the ongoing processes of homeostasis. In the allostasis, you can view as an additional process of re-establishing a balance, but one that responds to a challenge instead of an ebb and flow situation. So we can kind of think about blood pressure, kind of think about the pH of our plasma, kind of think about the core body temperature. They're kept under control by homeostasis. But sitting on top of that is the allostasis, which kicks into play when additional challenges impact on physiological function, i.e. stress, and then bring those changes back into place. So allostasis and stress are two concepts that go together because they talk about the concept of allostatic load. Now, allostatic load is essentially how much allostasis we are under in order to maintain homeostasis or in order to maintain allostasis. So allostatic load is really the cumulative wear and tear on the body that's accumulated due to trying to adapt to adverse physical or psychological challenges. So allostatic load is in fact something that quantifies stress. Okay? Now, so this is the rider that we were sort of getting at before, that measurement of stress is inherently flawed and inherently complex, as stress, as we've already learnt in session 2, is experienced subjectively. Some things are stressful to some people, some things are not stressful to other people. And they're experienced at different levels in terms of social, psychological, and physiological. Okay? So in terms of measuring stress, we can't just be measuring one biomarker and get that and say, aha, you're stressed because you've got this in high amounts. You should also understand that the stress itself can be experienced in different ways, and it can be experienced in different ways with respect to whether it's experienced physiologically, psychologically, or in terms of a change in social interaction. So, just to finish off our first session here, there's a horrifying slide that actually has a pretty good list of some of the biomarkers that are used to quantify allostatic load, or in other words, biomarkers that are used to quantify stress. And they're used, or they exist in all the different systems of the body, and within each system of the body you can see that there's many different biomarkers that may indicate a high allostatic load, or in other words, may indicate stress. In the cardiovascular system, there's a really important one that we will go into detail later on in this session called heart rate variability, or HRV. Blood pressure is a biomarker for stress. Heart rate is a biomarker for stress. Some of the markers that you've got in your blood that relate to stress are your triglyceride levels, your LDL, HDL levels, your glucose tolerance, your insulin resistance, your HbA1c levels, your albumin levels. So these are some common biomarkers that you've got in your blood that may indicate a high allostatic load. Markers in the immune system, so CRP is a C-reactive protein, which is a very common biomarker for stress, also commonly used to measure inflammation. TNF-alpha, interleukin-6, thrombin, fibrinogen. These are all biomarkers within the immune system that indicate there's a high allostatic load within the immune system. Remember, the rider to all of this is they can't be taken in isolation. So you need to also consider the patient's other signs and symptoms of stress, such as subjective and objective assessments of their own stress levels. Some of the common anthropometric markers of stress are BMI, waist-hip ratio. Some of the biomarkers for stress in terms of the endocrine system are prolactin, noradrenaline, dopamine, cortisol, and aldosterone. We'll go through HRV, cortisol, and some of the other biomarkers that are out there that are used to assess the allostatic load or to assess and evaluate how much stress someone is under. So, thanks for listening, and we'll see you in the next Camtasia where we'll go through some of the key biomarkers for stress. Bye now.